Peering deep into the universe, astronomers probe the clash of cosmic forces. The obliteration of matter and energy. We glimpse the limits of time and space in the strange death of a star. Here, astronomers have pinpointed solar systems in the making. When clouds like these become dense enough, nuclear fusion begins. Stars and solar systems are born. Another fate altogether awaits the exploding star at the center of this cosmic drama. In the wake of the blast, its highly compressed core remains intact. Imagine planet Earth compressed down to a tennis ball. That's a neutron star. Some can spin at incredible speeds, hundreds of times per second. When a so-called pulsar was first detected by radio telescopes, its signal was thought to have come from a faraway alien civilization. The Crab Nebula is the shell of the same supernova that caught the attention of so many cultures in the year 1054. Scientists have zeroed in on a pulsar deep within. They documented waves of radiation that have etched circular patterns in the surrounding gas. Some dying stars meet a fate that is stranger still. Nature, it seems, has contrived a monster. The scientist Albert Einstein once speculated about a star with such intense gravity that nothing, not even light, could escape its grasp. He dismissed this prospect as impossible. What once seemed beyond reason now defines the frontiers of science. Astronomers believe that when a star explodes, enough matter can collapse into its core that it literally exits the known universe. Gravity wins the final battle. From our vantage on Earth, we define our universe by familiar criteria, including the forms of light we find along the electromagnetic spectrum. But black holes defy discovery. How can we detect an object that emits no light? Astronomers spotted the answer in a flash of gamma radiation in the direction of the center of our galaxy. Radio telescopes zeroed in on the source and found jets of matter racing out in two directions. This is what they saw. A black hole that is drawing a stream of gas from a star's outer layers. As it flows in, it forms a spinning disk. The disk generates magnetic fields that twist around and channel some of the inflowing matter out into a pair of high-energy beams, or jets. Astronomers now know that black holes can pack so much energy into these jets that they accelerate to within a tiny fraction of the speed of light. It turns out that this black hole, known to us as GRO J1655-40, is streaking across space at a speed of 400,000 kilometers per hour, 4 times faster than other stars around it. Most likely, it was blasted like a cannon by the supernova that produced it. Black holes, with their ability to marshal extreme energies, are more than just curiosities in our universe. There is a breed of large black holes that dates back to the earliest times, when the first generation of stars were being born at a rapid pace. When these primordial giants died, some gave birth to black holes. Gravity force-fed these black holes a diet of stars and gas as matter collapsed into the first galaxies, and as small galaxies merged into larger ones. A few of these primordial monsters grew to billions of times the mass of our Sun. By launching powerful jets, they heated up the regions surrounding their host galaxies. That put a stop to the flow of gas into the central galaxy, stunting its growth and allowing smaller galaxies on the periphery to form and grow. But the impact of these black holes did not stop there. This image from the Chandra X-ray Observatory shows a cluster of galaxies called Hydra A. It's enveloped in immense hot cavities glowing in X-ray light. There is a jet visible in radio waves blasting out of its central galaxy. Gas along the edge of the jet was found to contain high levels of iron and other metals, probably generated by supernova explosions. By pushing these metals into regions beyond, The black hole seeded more distant galaxies with the elements needed to form stars and solar systems like ours. Supermassive black holes can be seen in nearly every large galaxy in our universe. We've caught a growing number in the act of powering massive jets. We are beneficiaries of the violent life cycles of stars. And yet, we are separated from them by scales of distance and time beyond anything we experience on Earth. That separation is thrown into sharp relief by the flight of the twin Voyager spacecraft launched in 1977. After exploring the outer planets and their moons, these crafts are now plying the outer limits of the solar system. Tens of billions of miles from Earth. Traveling at 16 kilometers per second, Voyager 2 will pass within 4 light-years of the nearby star Sirius. 290,000 years from now. From our tiny corner of the galaxy, we've discovered that stars not only light up the universe, they also seed it with the stuff of life. By witnessing the explosive end of a star, we gain fleeting glimpses into the power that shapes the universe and transforms worlds like our own.